What's going on, besties? Today we're going to be talking about the 15 most common ATI TEAS science chemistry questions that you're going to see on the exam. Starting with our first question. What is the chemical formula for water? Is it CO2, H2O, H2O2, or O2? And the correct answer is B. It is H2O. This is correct. Remember, when it comes to water, we're going to have 2 hydrogen atoms and 1 oxygen atom binded together. Looking at our other answer options, we have carbon dioxide, which is CO2. Remember, with carbon dioxide, it's in the name. It has carbon, that's the C, and dioxide means that we have 2 oxygen molecules. So this is actually a byproduct of cellular respiration that we breathe out. C is also incorrect. This is actually the chemical formula for hydrogen peroxide. And what's cool about hydrogen peroxide is it's really reactive when it comes to water. So if you were to actually pour hydrogen peroxide into a cut, what it's doing is it's actually breaking down that water and oxygen into gas. And then lastly, we have good old O2, which is known as a diatomic oxygen atom. So remember, when we're talking about chemistry, a lot of our atoms want to be stable. And sometimes when they're just left alone, they're unable to do so. So in this particular case, these 2 oxygen atoms are going to share valence electrons, making it more stable. So our next question says, which of the following is an example of an exothermic reaction? Is it melting ice cubes, burning wood, boiling water, or photosynthesis? And you're absolutely correct. The correct answer is going to be B, burning wood. So there's 2 different kind of reactions you're going to need to know for the T's. Number 1 is exothermic reaction. The way I like to remember that is think of EX and XO, EX and EXIC. That means that heat is going to be exiting during this reaction. We're going to be releasing heat. In contrast, we have endothermic reactions. You can think of this as EN and endothermic, EN and enter. This means that heat is going to have to enter or be absorbed during the reaction for it actually to occur. So if we're talking about burning wood, this is a great example of an exothermic reaction. It's also a combustion reaction. The process of burning wood is going to release heat and light into the environment. Classic exothermic reaction. Well, let's take a closer look at the other one. So we have melting ice cubes. This is actually an endothermic reaction because it has to absorb heat from the surrounding in order to cause that melting to occur. No heat, no melting. Next up, we have boiling water. Think about it. It's the same situation as ice. Water has to absorb heat into its system in order to change a liquid into a gas, making this also endothermic. And then lastly, we have photosynthesis. So this one's a little bit of a tricky one, right? What's interesting about photosynthesis is it is actually an endothermic chemical reaction. Plants are actually going to absorb light energy to build up glucose. It requires energy input from the sun in order to make that happen, making it endothermic. A student dissolves NaOH in water and the temperature of the solution rises. What can be concluded? Is it that the dissolution is exothermic? The dissolution is endothermic? The solution becomes less basic? Or the NaOH forms covalent bonds with water? And the correct answer for this one is going to be A. The dissolution is exothermic. So you might be thinking to yourself, what on earth is NaOH? So what it stands for is it stands for sodium hydroxide. Remember, anytime that we have something ending in OH or it ends in oxide or nates, we're talking about bases, not acids, bases. So if we have a base that's being put into a solution, which is water, the temperature is going to rise. That is what NaOH does. It dissolves in that water. It ionizes into 2 things, sodium, that's our Na, and OH, hydroxide, which is our OH ions. And this process releases energy as heat. This is why if you're holding a beaker when this process is happening, it starts to feel warm. It's a classic exothermic reaction. But let's take a closer look at our other answer options. So we have B, the dissolution is endothermic. Remember, endothermic reactions are actually going to absorb heat from its surroundings. So if it's absorbing heat, it's not going to cause the temperature to rise. The temperature would actually drop in this type of situation. Then we have C, the solution becomes less basic. This is also incorrect. Why? Because this is literally telling you that it is a base. So if we're adding more bases to a solution, the solution is going to become more basic, not less. Remember, NaOH is a very strong base, and when it dissolves, it increases our hydroxide concentration in the solution. That's going to raise our pH, not lower it. And then lastly, we have NaOH forms covalent bonds with water. This is also incorrect. Sodium hydroxide is actually going to form ionic compounds when it dissociates in water. It does not form covalent bonds. So let's talk about that. Sodium, which is our Na, is a metal, and it has one lonely electron on its outer shell. Remember, we love stability when it comes to chemistry. So what is it going to do? It's going to want to get rid of that electron to feel more stable, right? With hydroxide, that's going to carry an extra electron, right? So it's going to take the donated electron from our sodium and it's going to receive it on our hydroxide. So again, that is what's happening there. Remember, covalent bonds share electrons. Ionic bonds donate, lose, or gain electrons. So which of the following is the atomic number of an atom that has 12 protons and 12 neutrons? Is the number going to be 24, 0, 12, or 6? And the correct answer for this one is going to be 12. So let's talk about it. So when we talk about the atomic number, it's going to be found up here on the upper left of your element tile. And that tells you how many protons are in an element. Down towards the bottom here, you can see the atomic mass. And the atomic mass tells us how many protons and neutrons are in an element. So the way that I like to remember this is using PAN-MAN. So PAN stands for protons, atomic number, number of protons, and MAN stands for mass number, add your neutrons. Looking at our other answer options, we have 24. That is obviously not the correct answer. That means that we would be adding both of our neutrons and protons together. So if we were looking for the mass number, sure, absolutely, it would be 24, but in this case, we're only looking for the atomic number. Then we have 0. You're not going to find any atoms that is going to have 0 atomic number. It's just impossible, right? That would mean that we have 0 protons, and that just doesn't exist. And then lastly, D is 6. This is actually the atomic number for carbon. So we're actually looking for an atomic number with 12, right? 12 protons. If we're only having 6 protons, we're looking at a completely different element, making D the incorrect answer. Which of the following explains why noble gases are generally unreactive? Is it because they have a low atomic mass? They are nonpolar molecules? Their outer electron shells are full? Or they're always found in ionic compounds? And you guessed it, the correct answer is going to be C. Their outer electron shells are full. Remember, noble gases are unreactive because they have this complete outer electron shell known as the valence shell. Typically, it's going to contain 8 electrons. Remember your octet rule, which states that atoms are most stable when they have 8 electrons in their outermost shells. Let's look at our other answer choices. So A, they have low atomic mass. So here's the deal. Some noble gases do have a relatively low atomic mass, but it's not the primary reason why it's unreactive. The stability of that outer shell is the reason for that low reactivity. Then we have B, they are non-polar molecules. So again, being non-polar does not contribute to the lack of reactivity in some molecules. It's just not the fundamental reason behind why noble gases would be unreactive. And lastly, D, they're always found in ionic compounds. So noble gases are never found in ionic compounds. Think about it. What is ionic compounds? What is ionic sharing? They're either donating or receiving electrons. Noble gases don't need that, right? Because they're already very good in regards to their valence electrons. They're stable, they're full. So noble gases don't tend to lose or gain anything. They are just unreactive gases, meaning that you're not going to find them in covalent or ionic compounds. So nitrogen gas is an extremely stable molecule because of which of the following? Is it because it has a full outer shell of 6 electrons? It forms a single bond with other nitrogen atoms. It has a low electronegativity, or forms triple covalent bonds. And that's right, the correct answer is D. It forms triple covalent bonds. So each nitrogen atom shares 3 pairs of electrons, with the other forming a triple covalent bond. It is one of the strongest bonds in chemistry, which makes nitrogen gas, which is N2, very stable and unreactive under normal conditions. Well, let's look at our other answer choices. So we have A. It has a full outer shell of 6 electrons. Remember your octet rule. It does not need 6 electrons in order to be stable. It needs 8 electrons in order to be stable. So we can automatically rule this one out. B would also be incorrect. B is it forms a single bond with another nitrogen atom. We just talked about that. It actually shares 3 electrons, not 1. So this would also be incorrect. And then lastly, C, it has a low electronegativity. That is also incorrect. Nitrogen has a high electronegativity due to its, number 1, small size. Number 2, it is highly effective with its nuclear charge. And 3, the proximity to completing its octet by the use of triple covalent bonds. So these factors combined create a strong attraction for electrons in chemical bonds. So which of the following substances contains the greatest number of atoms? Is it 1 mole of H2, 1 mole of NaCl, 1 mole of H2O, or 1 mole of O3? And the correct answer for this is going to be C, 1 mole of H2O. So how do we break this down? Just like we did in our chemistry video, if you haven't seen how to calculate moles, I highly recommend that you go back and watch it. This is how we figure out how many atoms are found in a mole. So if we were to look at our correct answer, we know that we have 2 H2 molecules, right? So that's 2 atoms right there. And then we have 1 oxygen molecule. That gives us a total of 3 atoms altogether. Let's look at the other ones. So H2, we already know because it has a subscript of 2, we only have 2 atoms in that particular mole. So this would give us 2 atoms, which is less than 3, making that the incorrect answer. Now looking at our NaCl. Na is 1 element and our Cl is another element. But again, we don't have any coefficients or subscripts based on this particular molecule, meaning that we only have 2, 1 Na, 1 Cl, making it 2. That's also less than 3. That's also going to be incorrect. And then lastly, same thing like we have with H2, oxygen also has a subscript of 2. There's no additional information there or atoms connected to it. So again, we only have 2 atoms here, making it less than 3, making D also the incorrect answer. And C is the correct answer with a total of 3 atoms. Which of the following summarizes a change that takes place as a solid turns into a liquid? Do particles become less ordered? Particles completely stop moving? Temperature decreases drastically? Or particles gain protons and neutrons? So the correct answer is A, particles become less ordered. So let's think about it. The question is saying that we have a solid that's going to turn into a liquid. So what do we need in order to make that happen? We need heat. As we know, with our solid elements, we're going to have a whole bunch of particles are going to be tightly packed and ordered, and they still move, which is the reason why B is incorrect. When it talks about things stop moving, remember, we don't like no words. We don't like definitive words. Stop, always, everyone, all those types of words, not good words. So that automatically tells you that B was the incorrect answer. But yes, we've got all these particles, they're all packed together, they're all vibrating in place, they're in an orderly fashion. Once we start turning up that heat, like we see in this chemical reaction, the particles are going to become less orderly. They're going to start to move around. They're going to have more space, right? They're going to be bouncing off of each other. So that is the reason that A is the correct answer. Looking at our other answer options, we have C, temperature decreases drastically. Again, we need heat in order to make this happen. So it wouldn't make sense that we would be decreasing temperature. It would only make sense if we were going from a liquid to a solid. Then of course we would see temperatures decreasing. But this particular chemical reaction, we're going the other direction, meaning that we're going to need some heat. And then lastly, we have particles gain protons and neutrons. This would actually describe a nuclear change. And in this particular question, we're having a physical change that's taking place. Melting involves the movement of particles, not changing the atomic structure. Atoms are going to remain the same, they're just going to be arranged differently and moving. Which of the following describes the role of a catalyst in a chemical reaction? Does it increase the activation energy? Does it decrease the energy of a product? Does it increase the temperature of the system? Or does it give an alternative pathway with lower activation energy? And you've guessed it, the correct answer is going to be D. It gives an alternative reaction pathway with lower activation energy. So let's take a closer look at our example over here on the right side. So if we were to look on our y-axis, this is the energy axis, and our x-axis, this is the progress of the reaction. If we were to look at something that, say, didn't have a catalyst, that would be our blue line right here. It's going to need a lot of energy in order to make that happen. That's why you see such a stiff rise before it eventually falls and creates our product. However, if we were to add a catalyst to this particular type of reaction, it's going to need way less energy than it would without it. So this would absolutely make D the correct answer. It gives it that alternative pathway by lowering that activation energy. Looking at other answer options, we have A, increases the activation energy. We know that's incorrect. We just literally talked about that. It actually decreases the energy, not increases it. B, decreases the energy of the product. So the energy of the product is always going to stay the same. The catalyst does not alter what's happening at the end, which is the reason that B is incorrect. And then C, increases the temperature of the system. Catalysts do not change temperatures when it comes to reactions. It only changes the activation energy, which is the reason why C is incorrect. Which of the following occurs in an oxidation reaction? Do we gain protons, remove electrons, decrease in oxidation state, or absorption of neutrons? And the correct answer for this is going to be B. It is the removal of electrons. So in redox reactions, there's two different kinds of reactions. Number one, we have an oxidation reaction and we have a reduction reaction. So the way that I like to remember how this takes place is I like to think of oil rig. Oil stands for oxidation is loss of electrons, and rig is reduction is gaining electrons. So if we have an oxidative reaction, which is what it's asking, then we are actually losing electrons, not gaining electrons. Let's look at our other answer options. So we have A, gaining of protons. I cannot say this more clearly. It's so important when it comes to the T's and chemistry. Protons define an atom's identity. And if you were to gain protons, it's actually going to change what the atom is altogether, right? If I have an atom that has 6 protons, like we see in carbon, and I was to add 2 more to those, the atom is no longer carbon. It's a completely different element. And this is not what happens in a standard oxidation reaction. Then we have C, it decreases the oxidation state. So oxidation does not decrease, it actually causes an increase in oxidation states because the electrons are negative, and by losing them, the atom becomes more positive. And then lastly, we have D, the absorption of neutrons. Neutrons affect specifically the mass number of an element, not the oxidation state or chemical behavior of a redox reaction. Which of the following is a physical change, not a chemical change? Is it iron rusting, wood burning, water boiling, or vinegar reacting with baking soda? And you've guessed it, the correct answer is C, water boiling. Remember, when we boil water, that change that's occurring is changing the state of the matter, not its identity. We're only having a physical change, not a chemical change. We see chemical changes with our other examples. So A, iron rusting. We're actually forming a new substance called iron oxide. This is a chemical change, not a physical change. Wood burning, same situation. We're burning new products. We're creating gases and ashes. That is a chemical change. And then lastly, this is kind of like a gimme, vinegar reacting with baking soda. That bubbling that's occurring when they react is actually forming carbon dioxide gas, also a chemical change. So which of the following atoms is likely to become an anion? Is it fluorine, who has an atomic number of 9, sodium, atomic number of 11, magnesium with an atomic number of 12, or neon with an atomic number of 10? And the correct answer is going to be A, fluorine. So in order to answer this question, we have to understand the differences between anions and cations. So number one, an anion is a negatively charged ion. Remember our example of the angry onion, the angry ion? That lets us know that we have something that's negatively charged, meaning that it needs to gain electrons in order to make it more negative. In contrast, when it comes to a cation, this is more of a positively charged ion. Think of cat paws, right? Positively charged ion. So that means that we're going to have to lose electrons in order to make that happen. So let's look at the chemical breakdown of each one of these elements, starting with our correct answer. So if we were to look and break it down by the shells and how many electrons are in each shell, we know that we have 9 electrons. So our first shell, our 1s, is going to have 2. Our second shells, our 2s and our 2p, are going to have 2 and 5 accordingly, right? 5, 2, and 2 make up 9. That's how we get our 9 electrons. So in this case, we're missing 1 valence electron. So in order for this element to become stable, that means it needs to gain at least 1 more electron to be stable, making this a classic example of an anion. Looking at our other options, we have magnesium. So magnesium, we've got 2 in the first, we've got 8 in the second, and then we've got 2 in the third shell. So anytime we see things that are less than 5, typically that means that they can lose those electrons and still be okay. In this case, they only have 2 electrons in its valence shell, so they could absolutely lose that, making it a cation. Same thing goes with our sodium, right? We have 11 electrons. So the first has 2, the second shell is going to have a total of 8, and then the last shell is only going to have 1. So they could absolutely afford to get rid of that last valence electron, making their last shell, if they were to lose it, a total of 8, right? Making that the octet rule. This would make sense. And they absolutely would become a cation. And then we have neon. So remember, neon is one of our noble gases, meaning that they are not really reactive and they're extremely stable. So if we were to break it down, they have 10 electrons. So we have 1 in our S shell, and then of course 8 in our valence shell, making it very stable. It's a stable element, it's unreactive, it doesn't need to gain or lose electrons in order to find stability, making this just a stable element. So what happens to the pH when a strong acid is added to the solution? Does the pH increase? Does the pH become 14? Does the pH remain constant? Or does the pH decrease? And you got it, the correct answer is going to be D, the pH increases. So this question is talking about a strong acid being added to a solution. We know that if we were to add an acid to a solution, it's going to cause our pH to shift to the left in the more acidic range. And that is the reason that D is the correct answer. The pH is going to decrease to the lower numbers because that's where all the acid is on our pH scale. Let's look at other answer options though. pH increasing. This would mean that we would have to add a strong basic type of solution. In order for us to have that happen, that would mean we would shift to the right if we were to add a base. And in this case, that's not what we're adding. We are specifically adding a strong acid, which is the reason that A would be incorrect. B would also be incorrect if you think about it, because 14 is all the way down here on the alkaline basic scale. So we wouldn't be shifting to the right, we would be shifting to the left, making B also the incorrect answer. And then of course, C doesn't make any sense. If we were to add something to a solution, there's gonna be some kind of change. So nothing remains constant when it comes to our pH scale. So a freshly cut avocado tends to turn brown when exposed to air, but squeezing lime juice over the surface helps it stay green. Which of the following best explains this effect? Is it that lime juice rises in temperature and speeds up oxidation? Does it lime juice has a pH that inactivates the enzymes responsible for browning? Does the water in the lime juice dilute the color change? Or is it that lime juice reacts with oxygen to produce energy? And the correct answer for this is going to be B. That lime juice has a pH that inactivates the enzymes responsible for browning. So if you think about it, lime juice is a very acidic environment. And what it does is it's going to inhibit one particular enzyme called polyphenol oxidase enzyme, which is responsible ultimately for the browning of our avocado. So this is absolutely going to slow or even stop that browning process. Then we have A. Lime juice raises the temperature, speeding up oxidation. So lime juice has nothing to do with temperature change. It is due to oxidation when it comes to browning. So lime juice does not heat up our fruit, making A the incorrect answer. Then we have C. The water in the lime juice dilutes the color change. While moisture is present, it's actually the acidity, not the actual water content, that's going to block the browning. And then lastly, we have D. The lime juice reacts with oxygen to produce energy. Lime juice doesn't react with oxygen in that way. It's not producing energy, right, like we see with cellular respiration and mitochondria, but it's rather preventing enzyme activity, making D the incorrect answer. Using the formula pH is equal to negative log H plus, a solution with a hydrogen ion concentration of H plus is equal to 10 raised to the power of negative 1 m has a pH of which of the following? 0, 10, 1, or negative 1. So this question seems really scary, but it's actually not. The correct answer is going to be C. Let's talk about it. So what the question is giving you is it's giving you the concentration of H, right? So that's this part of our equation right here. So if we were to rewrite this out, we would do pH is equal to negative log, and then inside here, we would do 10 raised to the power of negative 1. So if we have a negative power, like we see here, and we have a negative log, all we're really doing is multiplying those two things together. Remember, a negative is going to cancel out a negative. So we would actually see a pH of 1. Negative log multiplied by negative 1 gives us our answer of 1. This would be the same if you saw in any other situation. If we had 10 raised to the power of negative 3, that means our pH would be 3. If we had 10 raised to the power of negative 7, that means our pH would be 7. So looking at our other answer options, we have A, 0. That's also incorrect. That would mean that our H plus would equal 10 raised to the power of 0 m, which is our moles per liter. That's more acidic than what this specific example is saying, which is the reason why A is incorrect. Same thing goes for B. That would be H plus raised to the power of negative 10 m. In this case, that would be more basic, right? Would be in the opposite end of the pH scale, making this one also incorrect. And then we have D. So pH values are typically on a scale of 0 to 14. So in this particular case, with having a negative number, that means that we would be seeing something off of the scale. It's very rare that we would have a negative pH. It only happens in extremely super acidic solutions. But for the ATI TEAS, you don't necessarily need to know that. You just need to know that scale of 0 to 14. So in this case, D would also be incorrect because it's just not something that's going to be on the test. All right, besties, that's the most common 15 questions that you're going to see in the chemistry portion of the TEAS. If you want additional questions that are going to help you with feeling a little bit more confident when it comes to those exams, make sure that you check out this playlist right here. Until next time, I'll catch you in the next video.